We look up at the night sky. Thousands of stars pepper the darkness, each one a distant sun, possibly with planets of its own. A simple question arises, ancient yet persistent. Are we alone? This question has haunted humanity for millennia. It fuels our imaginations and drives our scientific endeavors. The universe is vast, its true size still unknown. This vastness makes it statistically improbable that we are the only ones out there. The thought of other beings, other intelligences, is both exhilarating and terrifying. It speaks to a deep-seated need within us to connect, to find meaning in the grand tapestry of existence. Are there others who gaze upon the stars with the same sense of awe and wonder? Do they ponder their place in the cosmos as we do? These questions are fundamental to our understanding of ourselves and our place in the universe. We yearn for connection, for proof that we are not alone in this vast cosmic ocean. The search for extraterrestrial life is not just a scientific pursuit, it is a reflection of our shared humanity, our desire to find kinship among the stars. It is a journey of discovery, not just of new worlds and new life forms, but of ourselves. Consider this. Our galaxy, the Milky Way, contains hundreds of billions of stars. Each one of these stars is a potential host for a planetary system, much like our own solar system. The sheer number of stars in our galaxy alone is mind-boggling, and it gives us a glimpse into the vastness of the cosmos. And the Milky Way is just one of billions upon billions of galaxies in the observable universe. Each galaxy, in turn, contains its own multitude of stars, each with the potential to host planets. When we consider the number of galaxies, the number of stars, and the number of potential planets, the scale becomes almost incomprehensible. The sheer scale of these numbers is staggering. It's a humbling reminder of how small we are in the grand scheme of things. The universe is vast beyond our wildest imaginations, and we are just beginning to scratch the surface of understanding it. It boggles the mind to try and comprehend the vastness of it all. Each point of light in the night sky represents a star, and many of those stars have planets orbiting them. The night sky is a window into the immense and awe-inspiring universe that surrounds us. Amidst this cosmic ocean of stars and galaxies, planets are not an anomaly, they are the rule. Planets are a common feature of star systems, and they come in a wide variety of sizes, compositions, and environments. Astronomers now believe that most stars harbor their own planetary systems. This means that there are potentially trillions of planets in our galaxy alone, and even more when we consider the entire universe. These exoplanets, as they are known, come in a stunning variety. Some are gas giants larger than Jupiter, while others are rocky worlds like our own. There are also ice giants, water worlds, and planets with exotic atmospheres and compositions. Some are gas giants larger than Jupiter with thick atmospheres of hydrogen and helium. These planets are often found in the outer regions of their star systems, far from the heat of their parent stars, while others are rocky worlds like our own, with solid surfaces and the potential for liquid water. These rocky planets are often found in the habitable zones of their stars, where conditions might be right for life to exist. Many reside within their star's habitable zone, the region where temperatures allow for liquid water on the surface. This is crucial because liquid water is essential for life as we know it. The habitable zone is often referred to as the Goldilocks zone, because it is not too hot and not too cold, but just right for life. Liquid water is essential for life as we know it. It is a solvent that allows for the chemical reactions necessary for life to occur. Without liquid water, life as we understand it would not be possible. With so many stars and planets, the potential for life elsewhere seems incredibly high. The sheer number of planets in the habitable zones of their stars suggests that life could be common in the universe. The ingredients for life as we know it, water, organic molecules, and a source of energy, are abundant throughout the universe. These building blocks of life are found in interstellar clouds, on comets, and even on the surfaces of planets and moons. It is becoming increasingly clear that the conditions necessary for life are not unique to Earth. Many planets and moons in our own solar system have environments that could potentially support life, and the same is likely true for planets around other stars. The building blocks of life are scattered across the cosmos. Organic molecules, which are the precursors to life, have been found in a variety of environments, from the icy moons of the outer solar system to the interstellar clouds where stars and planets are born. Organic molecules have been found in interstellar clouds, the nurseries of stars and planets. These clouds are rich in the complex chemistry that is necessary for life to begin. These molecules, the precursors to life, are constantly being formed and reformed in the vast expanse of space. The processes that create these molecules are ongoing, and they provide the raw materials for the potential emergence of life. The universe seems to be teeming with the potential for life. With so many stars, so many planets, and so many environments that could support life, it seems almost inevitable that we are not alone in the cosmos. The search for life beyond Earth is one of the most exciting and profound scientific endeavors of our time, and it is a journey that is just beginning. Given this potential, why haven't we detected any signs of extraterrestrial life yet? This is the heart of the Fermi paradox, named after physicist Enrico Fermi. He famously asked, "Where is everybody?" It's a simple question with profound implications. If the universe is teeming with life, why haven't we encountered it? There are many possible answers. Perhaps interstellar travel is simply too difficult or too expensive. The distances between stars are vast, and even traveling at a significant fraction of the speed of light, a journey to another star system would take many human lifetimes. Or perhaps intelligent civilizations are inherently self-destructive. They might develop advanced technologies but wipe themselves out before they can reach out to the stars. Another possibility is that alien civilizations are out there, but they're choosing not to communicate. They might be observing us from afar, studying us like scientists study a colony of ants. Or maybe they simply have no interest in interacting with other intelligent species. The reasons for their silence remain a mystery. It's also possible that our methods of searching for extraterrestrial intelligence, SETI, are flawed. We've been primarily listening for radio signals, but what if advanced civilizations have moved beyond radio communication? What if they're using technologies we haven't even dreamed of yet? Our search methods might be too limited, too focused on finding life that resembles our own. Consider the possibility that advanced civilizations have visited Earth in the distant past. Some theorists suggest that ancient structures and artifacts could be evidence of such encounters, yet these ideas remain speculative and controversial. Another intriguing idea is the concept of the Great Filter. This hypothesis suggests that there is a stage in the evolution of life that is extremely difficult to surpass. It could be the emergence of life itself, the development of complex organisms, or the leap to intelligent, technologically advanced civilizations. If the Great Filter lies ahead of us, it could mean that many civilizations reach a certain point and then fail to progress further. Alternatively, if we have already passed the Great Filter, it might explain why we haven't encountered other advanced civilizations. The universe is vast and full of possibilities, and our understanding of it is still in its infancy. As we continue to explore and learn, we may one day uncover the answers to these profound questions. Until then, the silence we perceive remains one of the greatest mysteries of our existence. The search continues. We've been searching for extraterrestrial intelligence for decades, primarily by listening for radio signals. This method has been the cornerstone of our efforts, driven by the assumption that other civilizations would use similar technology to communicate across the vast distances of space. This approach assumes that alien civilizations would communicate using radio waves, just like we do. Radio waves have been our go-to method because they travel long distances and can carry a lot of information. But is this assumption limiting our search? But what if they've moved beyond radio? What if their methods of communication are so advanced that they make our technology look primitive in comparison? What if their technologies are so advanced that our current methods are like trying to find a needle in a haystack using a magnet that's too weak to pick it up? The universe is vast and our tools might not be up to the task. Imagine trying to explain the internet to someone living a century ago. They might grasp the basic idea of sending messages over wires, but the full scope of the internet, with its social media, streaming services, and online gaming, would be beyond their comprehension. They might understand the concept of sending messages over wires, but the vastness and complexity of the internet, with its social media, streaming services, and online gaming, would be beyond their comprehension. This analogy highlights the potential gap between our current technology and that of an advanced alien civilization. Similarly, alien civilizations might be communicating in ways we can't even imagine. They could be using technologies that are as incomprehensible to us as the internet would be to someone from the early 20th century. Instead of just listening for radio signals, we should be exploring other possibilities. We need to expand our horizons and consider alternative methods of communication that might be used by advanced civilizations. Perhaps we should be looking for signs of advanced technology, such as Dyson spheres, hypothetical megastructures built around stars to harness their energy, or other evidence of large-scale engineering projects. These structures would be a clear indication of a civilization far more advanced than our own. We need to think outside the box and consider that alien civilizations might be far more advanced than we are. Their technology could be so sophisticated that it defies our current understanding of physics and engineering. Our current methods might be too Earth-centric, too focused on finding life that resembles our own. We often look for planets with conditions similar to Earth, assuming that life elsewhere would need the same environment to thrive. Life on other planets could be radically different from anything we've ever encountered. It might thrive in environments that would be hostile to us, with biology that operates on principles we have yet to discover. It might not even be carbon-based or require water to survive. We need to consider the possibility of life forms that are fundamentally different from those on Earth, perhaps based on silicon or other elements. We need to broaden our search parameters and be open to the possibility of life as we don't know it. By expanding our search criteria and considering a wider range of possibilities, we increase our chances of finding evidence of extraterrestrial intelligence. The universe is vast and full of mysteries, and our quest to find other intelligent life forms should be as boundless as the cosmos itself.